In this next section, we're going to talk about how to get information about graphs from the pictures of the graphs. So some of the information that we can pull from a graph are some things we've already talked about, which are the domain and range, which again is the input and the output of the function. The intercepts, which again is where the graph is crossing the x or y axes. But the two that we haven't quite talked about are the general slope and the extreme values. By general slope, we just mean increasing, decreasing, or constant. So what is the graph doing as we move from one point to another? And then the extreme values tell us, aside from the infinite values, so positive and negative infinity, where are the highs and lows on the graph? So the local maxima and the local minima. Okay. So before we can look at this information and use that information in graphs, we need to know what we mean by these things. Okay. So for general slope, a function f of x is increasing on the interval from a to b if for all x1 less than x2 in the interval, f of x1 is less than f of x2. Okay? So here that just means if I'm looking on my x-axis and I have 2 points, x1 and x2, that are in this fashion where x1 is to the left of x2, if the value of the function is less there than it is there, then the function is said to be increasing. And now the way I've drawn this, my values for the function are both above the x-axis, but it really doesn't matter where they are. They could be below, they could be on it, but as I move from the left to the right, if the value on the left is smaller than the value on the right, then I know it's an increasing function. A function f is said to be decreasing on the interval from a to b if, again with the same setup, I have some x1 less than x2 in the interval, that the value for x1 is bigger than the value for x2. So here in my picture, what we're looking at is again on my x-axis, if I have my points set up in this fashion, so again x1 to the left of x2, then my value here for x1 is bigger than my value for x2, and so my function is said to be decreasing. And in both cases here, we can kind of see that the general slope there is positive, and the general slope here is downward or negative. Okay. The last case that we're going to look at is if a function is constant. And so this tells us that if I take 2 points, x1 and x2, and it doesn't matter the ordering here, as long as they aren't equal to each other, then if the function values are equal, then it's a constant function. So again, I'm just going to pick an x1 and x2 with our general orientation. Again, it doesn't matter which is less, but if my value here happens to be the same as the value here, then I'm looking at a constant function. And another way to describe a constant function is that we're looking at a horizontal line. That's what the graph of a constant function will look like. Okay. For the extreme values, to get information about the graph in terms of the extreme values, we're going to look at what is happening around particular points. So the function value f of a is a local maximum value of f if for every a, f of a is greater than or equal to f of x if I'm close to x. Okay? And so this is also saying that f has a local max at a. Okay? So in this one, if I'm looking at kind of the picture here, I have some point A, and I have some interval around it. We don't care how big that interval is, but we're going to assume it's near it. And so near could be a couple of units, it could be some fraction of units, or it could be some large number of units. But if I look at the value here, and every other value is less than that, so something that looks like this, then this is the max value, and this is the point, or the x, where the max occurs. The same thing is true for a local min. So if I have a b, f of b is the local minimum value of f, if f of b is less than or equal to f of x for every x near b, and the local min is at x equal b. So here's my point b, here's my interval, I've got some point here, and every value within that interval has a greater value than that one. So this would be my local min, and this would be the x where min occurs. Okay. And so what's going to happen for you is you are going to be given graphs of functions and asked to determine this type of information. So you're going to want to look at the open intervals where the function is increasing, decreasing, or constant, and you're going to want to find on the graph those points that look like local maxes or local mins. Okay. Now again, this is in addition to the stuff we've already talked about, like being able to find the domain, the range, and the intercepts. And eventually we're going to be able to use all of this information and go the other direction. So given a function, if we can find all of these things, then we can actually get a picture of the function.